Hi there, welcome to my channel Mando to Fundo. In this video, I'm going to discuss about the solution for finding the cycle in a linked list. Let's look at the problem description. We are given a head of the linked list. We have to return true if there is a cycle in the linked list. In addition to the head pointer, there is one more hidden input is also given, that is position. Basically that tells where the last node's next pointer pointing to. So in this case 0 1 2 3, so it says 1 and here it says 0, and if there is a no cycle then it will say -1. So the number of nodes in the list is in the range of 0 to 10 to the power 4, and the node value is -10 to the power 5 to 10 to the power 5, and the POS value is -1 or valid index within that linked list. We have to come up with a solution which uses constant space. We look at the different approaches to solve this problem. So the input given is this, the linked list is 3 2 0 -4, and the tail points to the first index, which is 2. Because this is greater than -1, there is a cycle in this linked list. So there are two solutions. One is using the hash map, and the other one is using the 2-pointer. So first see the hash map approach. So we can build the hash map as we traverse the linked list. So whenever we visit a node, we store the address in the hash map, and then as we move the pointer to the next node, we check whether the next node's address is the same as the one present in the hash map. So each time we check next pointer already exists in the hash map, that means there is a loop. So in this case we have to build the hash map, which requires order of n in the worst case. If there is no loop, then we at the end, when we reach this end, we will be having the hash map with 4 entries in it. So the space is order of n. So but the question was whether we can do it in the order of 1 space. Basically we can maintain a 2 pointers. One is a slower pointer and a faster pointer. Slower pointer points to the head, the faster pointer points to the second node in the list. We will advance these pointers until we reach the end of the list. Or we deduct the loop. We check whether these 2 pointers are not null. If so, we try to advance the slower pointer by 1 node, the faster pointer by 2 nodes. From here it will point to here. This node points to here. So each iteration it will be doing like that. Slower pointer move 1 node forward, this one moves 2 nodes forward. So each iteration we check whether these 2 pointers are same, pointing to the same node or not. If we see the condition where these 2 points to the same node, then we return true. Otherwise we will end up reaching the tail node, then we will break out of the loop and then we return false. So in this case we just use only 2 pointers. We are not allocating space with respect to the input size. So this approach needs only order of 1 space. Let's look at the flowchart. Input for this procedure is the head of the linked list. First we initialize the return value to false and initialize the slower and a faster pointer to point to the head of the list and head, the second node in that list. Then we are entering that for loop where we check if both the pointers are not null, then we are entering the for loop. Otherwise we go out, we break out the for loop and return false. So inside the for loop we check whether the slower pointer equal to the faster pointer. If yes, we set the return value to true and then go out of and then return that value from this procedure. If not, then we check whether the faster's next pointer is not null, because we have to advance the faster pointer by 2 nodes. We have to make sure we are not hitting the null pointer exception. So for that reason we are checking that next pointer here, and then we move the slow pointer 1 node and forward, and faster pointer 2 nodes forward. So if the faster dot next is null, that means we are hitting the end of the list. There was no cycle. So we break out of the loop and then we come out and return false. Let's move on to coding. First I declare the slower and faster pointer. And then I initialize the return value to false. Next, the head pointer is checked for null. If it is null, then we return false. Otherwise, initialize the slower pointer with head and the faster pointer with head dot next. Then the for loop begins here. I check whether the both the pointers are not null. If so, it enters the for loop, and then there I check the slower pointer is equal to the faster pointer. That means there is a cycle in the list. So setting the return value to true and break out of the loop. Otherwise, I check for the update the slower pointer to move forward 1 node, and then I check the fast pointer's next node is not null, because we have to advance 2 nodes forward, so we have to make sure the null pointer exception is not happening here. So that's why the next pointer is checked, and then I use the faster's next of next. So basically we are advancing 2 nodes. Else, if the faster pointer's next pointer is null, then we break out of the loop. Finally, return the return value. Next, I'm going to run the test cases. All the tests passed. Next, I'm going to submit this program. Cool, it's accepted. Next, I'm going to do the code walkthrough with the sample input. We have the input list 3204 and it says position as 1, meaning the tail node points to the element in the position 1, which is 2 here. So that means there is a loop here, sorry, cycle here. That means there is a cycle here. So we have to return true. So initially the slower pointer points to the head and the faster pointer points to the second element head dot next. We compare these two pointers, not equal, so the value is false. Then the slower pointer advanced 1 node, faster advanced to 2 nodes. So we compare these 2 pointers, they are not same, so the value is false. From here the slower pointer advanced 1 node forward and the faster pointer 2 nodes. So from here we follow the link here, this is 1 and this is 2. So now both slower and faster pointer pointing to the same node. That means there is a cycle. So we return true. Next, I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. And this position indicates there is a loop. Let's see how many times this for loop runs. So first the head pointer pointing here, head next here. So they are not same. Iteration 1. And we advance the slower to 1 and this one to 2 points forward. So both are not same. So that is in iteration 2. And then slower pointer now move advanced to point 2, value 0. And this pointer advanced to, because of the loop, it ended up pointing to the same node 0. So we see the slower pointer and faster pointer points to the same node on the third iteration. So we return true. And time complexity is, so basically we have to, in the worst case, if there is no loop, we have to traverse the entire list. That depends on the number of elements in the list. So the time complexity is order of n. Next, the space complexity, we are not allocating any space. We are creating only few variables. We are not allocating any space with respect to the input size. So the space complexity for this solution is order of 1. Thanks for watching this video. Have a great day.